Dr. Jayaprakash has already joined our Google Meet. My aim is to introduce Dr. Jayaprakash to you people. So Dr. Jayaprakash is the Director of Technical Education, Kerala. He is a graduate from Government College of Engineering, Kannur, and he had done his MTech and PhD from IIT Delhi under Dr. Kothari and Dr. Bhim Singh sir. So he is an expert in power electronics, power systems side. So he has been working in different engineering colleges in Kerala, about an experience of about 26 years and so on. Dr. Jayaprakash is a very keen researcher. He has produced almost 3 to 4 students for PhD, and the session would cover the grid integration aspects of uh, electrical storage systems. So I welcome Dr. Jayaprakash to the session. Sir, please. Jayaprakash sir. Hello.
Am I audible?
Yes
Okay,
sir,
okay.
yes sir. Please
I'm
carry
trying
on.
to share my presentation also.
Yeah, your presentation is
Is
visible.
visible. Okay.
Yes. So just an introduction to this, the participants. The participants are people who are faculty members of engineering colleges throughout India. Okay, we have almost 200 participants who have registered, and almost 53 people have already joined. So we are expecting all the other participants also to join very soon.
Okay, then shall we?
Yeah. Please carry on, sir.
Yes. Okay, okay. So, okay, thank you very much. First of all, I'm congratulating all our organizers for organizing a FDP in the area of uh, energy storage systems. That's what I don't remember exactly what the title is. Anyway, the topic what is suggested to me is on grid connected storage systems for grid connected renewable energy. So, what I would like to share, I think it is visible. My slide is visible, I hope.
Yes, sir. Yes.
Yes, sir.
It is fine.
Visible.
Okay. Okay. So, I would like to discuss something on uh, grid connected solar PV integrated fuel cell battery pumped hydro storage system. So I don't want to go into the other areas. So what I think is that we will have a maximum of 1 hour where we discuss mainly about battery, hydro power, as well as fuel cell as a storage system. So my topic will be covering some of the research we have done in our lab, especially in our GCE Kannur power electronics lab. So we have some simulation results of this, as well as hardware results on our experiments. So we will cover the control aspects as well as the topology or the performance of these systems. Okay, we will conclude with a comparison study. So the hope all of I hope all our faculty in the area of electrical itself I don't know how many of you are in the
No, sir. We have
screen.
diverse people from civil, chemical, and so on.
Okay,
Also,
okay. Then it is better. It's better to know that way. Okay, I think then the first slide is very attractive to all of you. So we are all living in a condition where everybody is looking for renewable energy based power generation. Why it is very clear to everybody because of global warming and related environmental issues. We are all focusing on low carbon emanating alternative energy sources. So the option is renewable energy. And a general uh, figure is this one, where we are projecting almost 27% renewable energy sources in the year of 2017 and 100% by 2050. So some of the projections available in the literature, I think 2050 in a global scenario, mainly in renewable means if you see the first diagram, it is 29% which is shown here. It is about uh, uh, wind energy and solar energy. So solar energy and wind energy. If you see, solar energy is expected to be very high, 69% in 2050. That means in future.
sir, I
I'm
just
just as a
changed it.
reference. Hello, is that audible? Slide.
Hello.
This slide is not visible.
The first slide is visible, but
Yeah, the second one now I just shifted to second slide.
now it is visible, sir. Okay.
It's okay. Okay. I'm just coming to second slide only, where I would want to focus on one aspect, that is in future, whatever I have shown here, this 69%, that is the expected share of photovoltaic. Okay, so now everybody know the reason why photovoltaic is uh, so attractive. And in future, we are expecting 69% from photovoltaic for that on a global scenario. So why? Just I am going to the third slide. If something is there, you can just communicate to me. No issue. In between, also you can. I think I will turn off my video so that you will get more clarity in presentation. Okay. So I hope this is okay. So that is from current slide. I have just put it. So slide 4 is okay, I think. Is that okay? Slide PV and VEX.
Yes, sir.
Okay. So if something is there, you can respond to me, no issue. Because whatever I believe that whatever time we are spending in the very afternoon or evening session, it should be at least useful to all of us. Because I don't want to give something very high rocket science. It's only very fundamentals, sustainable engineering as well as our immediate future. Okay, so I am focusing on photovoltaic and wind energy converter system. So it is about irregular and unpredictable power. That's what the focus point. Why it is irregular? It is because if you think about wind, everybody know we cannot expect a steady wind always, and unpredictable. That's also true. Uh, in the same meaning. So the unpredictable has a slightly different also, because solar we can predict during daytime, and we can predict that it will not be available during the night hours. But wind we cannot sometimes predict. But there are some statistics based tools or maybe data in a particular location for a period of 2-3 years or more than that, with which we can predict. Okay, so that prediction of the solar and wind energy is another area of research as itself, and a lot of power system engineers are focusing on that, because without knowing the future energy availability, we cannot go for a grid connected system. Okay, maybe for our residential systems we can manage 1 2 kilowatt we can manage, but think about a scenario where out of our uh, if you take Indian scenario, the total power generation is something like 4.7 lakh megawatt. Okay, if in Kerala we say about it's 1,000 megawatt system or 2,000 megawatt system. As you see about Indian scenario, he used to talk about uh, 4.5 to 5 lakh megawatt system. So out of that, if 50% is solar or wind, so think about that scenario. Then what will happen to the power availability to our maybe residential, commercial, industrial consumers? So that's what one of the means a spark in this research, because it's highly varying in nature. Okay, I'm not talking about irregular, but varying in nature. So how to make this system somewhat reliable? Okay, so in future we are going to face this issue, and it's the reason is very clear. Okay, so now the solution is going towards a hybrid system. Okay, PV, wind, and some other renewable energy source like small hydro or everything put together, we can increase the reliability. So researchers are going in that area, increasing the reliability by hybrid systems. But it gives only a lower level of reliability, because we cannot expect that all this group put together, they will give a constant power generation like that. Especially in wind and solar, there is a very what normally people say is they behave like brothers, because if one is weak, the other will support like that. Because when evening period, especially when sun is going to set, so what normally happens is wind increases. We know the reason for offshore that uh, wind reason for that wind variation during evening and morning hours. So that expectation is there, and it is true somewhat also. But still, we have to go for some other system. That's why I'm talking about energy storage systems. I think the reason is very clear, because we have to store this renewable energy or the total energy generated to some mechanism, maybe battery, supercapacitor, or some maybe something like any other hydrogen production, or maybe pumped hydro. These are some examples come into my mind. So then we store this power during availability and use it during the time of when power is not available. Okay, the basic theme is very clear. It's very simple also, but how it's complicated only in technology. So how we do it in a modern power system? So there comes the real challenge. Okay, so a lot of studies are available on this aspect. So I'm not going to those things. Uh, Fuel cell, micro turbines, etc. This is also one point which I was just mentioning. Installed capacity is 4.75 lakh megawatt in India, and we are expecting a 50% renewable for electricity generation by 2030 or so. Think about the condition. Okay, India is generating power from solar and wind, and how we are going to manage the power system. Now we are able to manage power system because we have a base load plant like nuclear power plant, and then thermal power plant, and hydro is managing our speedy variations in demand. Okay, with that we are managing power system. People are very happy, but in future they will not be very happy. Power system people means the existing power system people cannot be happy, so they have to go for modern control mechanisms, and obviously that's why I used to say that power system MTech people and power system research people, they will have a bright future in coming years. I think that is true also. Some of you may agree with that. Now power system is not at all that much demand, but maybe in future everybody look into the aspects. Okay, so I am talking about this. Many researchers say this in terms of carbon dioxide emissions. You all know why it is so. If you have a project with carbon dioxide emission less, okay, you can say that compared to that technology, my project has a CO2 emission which is much lesser. Then obviously you will get a lot of funding for that project. That's what the importance. I think uh, These are some of the statistics drawn in the literature. I'm not going to these aspects. And year by year, power generation also, I don't want to discuss much. I'll show this graph where you can see two, three curves. One is solar PV, one is wind, the third one is all renewable put together. And these three curves, you can see it's an increase. And here there is other renewables slightly constant. Okay, and hydropower is not going to increase in future much because of saturation. Okay, so we cannot construct more dams and hydropower generations in future. Okay, so with this, these are all almost the same thing which I discussed. Okay, so first time I am coming into a grid integrated solar power conversion system. So here, what I would like to give one small diagram. I think even all electrical people, it will be very simple. Mechanical people can also understand, I think, some of the terms, because you can say AC grid, DC AC converter, DC DC converter, and PV array. So PV array is nothing but our solar panel. Okay, if you have a solar panel, you will get a DC voltage. Everybody know, because almost all I have seen a solar panel somewhere on rooftop, either in your own rooftop or some other's rooftop. It will be available. So they give a DC power supply, and that DC power supply from a single power cell is. It's very interesting to note that in one cell we get only it's a PN junction based device, which has a very basic principle of photovoltaic effect. I think everybody knows it's a basic science, where you get when it is illuminated with sunlight. So you will get a PN junction, semiconductor junction, where electrons or majority carriers cross this junction due to by absorbing this sunlight or solar energy, and it will cross that small potential of 0.6 volt. That is what we call this the band gap of that device. So with that zero point 0.6 volt and crossing, the flowing of this electrons is nothing but current. Okay, so you are having a small potential due to that PN junction, and with this light falling on this surface, the electrons or the majority carriers, they absorb that energy and cross that junction. So you can say that there is a charge flow. It is nothing but current. So if you have a voltage and a current, we can say that it is generating some power. Voltage into current is power. So you have a definitive value of voltage and definitely it's a very smaller in voltage. So with this 0.6 volt and a few milliampere or maximum 1 ampere. Okay, so it is a 0.6 volt and 1 ampere current, means it is only a 0.6 watt source. So 0.6 watt is nothing for a power grid is concerned. So what you do is you will connect because this require only centimeter square, a few centimeter square of area. So if you connect all these put together, we will get a series of 0.6 volt connected in series. So if you just take a simple mathematics of 100 0.6 volt cells in series, so it will be total voltage will be 100 into 0.60 60 volt. Okay, so 60 volt can be connected. So if you can make any standard voltage level, normally nowadays power system or power electronics people, electrical people, they make this voltage as nearly something like 48 volt or 24 volt, one panel. Okay, so one panel with hundreds of this kind of small power cells,
Yes,
so they
sir.
can give 48 volt or 48
Yes,
volt
sir.
or 48 into 1 ampere means it is a 48 watt. I
So,
hope that is clear.
no,
So with that simple concept, we can see that PV array, depending upon the area. So how much area is required is another discussion that I will come later. Okay. And with this DC-DC converter and DC-DC converter is it is increase or decrease the voltage. So 48 volt, which is the output of that panel, can be increased to something like 480 volt with a DC-DC converter. It is just like a step-up transformer kind of device where you will get 480 volt. And with this 480 volt on one side, a DC AC converter can make it AC. This is also a power electronics converter, nothing but some switches, and they can give an AC 230 volt 50 hertz per phase AC, if you have three such phases, we call it as a three-phase AC, and three-phase AC is connected to grid. So what you require for both these is a to control devices. So that control device is nothing but a digital signal processor or a microcontroller kind of devices. Okay, and this DC-DC converter can be a buck converter, boost converter. That electrical people will tell more about that one. And DC-AC converter is nothing but another kind of switching device. Okay, I hope this basic is very clear. I think that is the very basic of our discussion today. Okay, so then I am giving some aspects of how this is connected in grid and what are the issues and lot of
The
10 level.
slide is not moving.
Pardon?
Sir, slide is not moving.
Okay, so let me see. Is it okay now? Some change?
Sir, now it is. Yes, sir.
Why it is not moving? Any
Earlier
tips
it
for that
was
one? Why it is
slide
not
4.
moving?
Earlier it was slide 4. Now it is 12.
Oh, you should have told me why you are sitting, mom. Because already I was showing some diagrams and all. Okay, I was showing this diagram 11. Is it clear? 11. Slide number 11 with the block diagram.
Yes, sir.
Okay. Please, you can always ask me, no issue, because I am taking an effort only to make you understand some basic concepts, nothing more than that. Okay.
Yes, sir.
That's what at the very beginning also I told. Because you people are sitting here after your hectic daytime schedule and spending time on understanding some concept. Okay, just see this block diagram. I think this block diagram is clear now. Those who are comfortable, just please
Yes, sir.
answer my question so that I will get some uh, energy. Okay.
Yes, sir.
Okay, then you see this block. I was mentioning about this block diagram only. PV array, DC converter, DC-AC converter, and connecting to grid.
Yes.
I hope that aspect is clear.
Yes, sir. Clear. It's.
Okay, fine. Then then okay. This is what I was mentioning. The basic problem also. That is, you have a PV array and connecting to the AC grid. So during that time, this PV array, PV panel, you can make a rooftop. Maybe you will get a maximum of 3 kilowatt. Think about 100 rooftop. So 100 into 3, 300 kilowatt. Okay. So normally now with the central government scheme, everybody is installing 3 kilowatt solar panels on rooftop.
Yes, sir.
Okay, that 3 kilowatt rooftop panels, it's normally they are all connected with their battery. Now think about a scenario, your 100 rooftops are connected with, listen, I am getting a call, just 1 minute. Hello? 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 Hello, Arvind, I will call you later. Hello? ക്ലാസ്സിലാണ് ഹലോ Okay, sorry for the disturbance. Okay, because for me there are a lot of disturbance normally coming, but I expect that evening time disturbance is less. So let us come to that point. Solar power conversion systems, and I hope this diagram is visible now. Slide 14.
Yes, sir.
Okay,
It's
fine.
visible.
Yeah. Just see, try to understand the components. Is it showing just one slide or with my other slides also?
With other slide also.
Okay. Just to try to understand the components here. I have one more call, just attend. Hello. അരവിന്ദ് ഞാനൊരു ക്ലാസ് എടുത്തുകൊണ്ടിരിക്കുന്നു. ഞാൻ ജസ്റ്റ് അരമണിക്കൂർ. ഓക്കെ. ശരി. നാട്ടിലെത്തിയോ? Okay, sorry. Now it is clear. Ah, just try to understand about our system. So I am talking about this in a very beginning itself. We have a solar PV panel. Even sun is also available there. Okay, in the diagram itself. So what I am have shown here is it is connected with the switching devices. First one is a DC-DC converter, and second one is a DC-AC. And this side I have three lines, so nothing but our grid. So I am connecting this with grid. Okay, so now whenever PV is illuminated with solar power, sun's radiations, we can inject power to grid. So that is not enough always. So that's what I'm saying. During evening hours, when power is not available, what we do? So so simple suggestion is a battery energy storage system. In Kerala, I think KSEB has started a battery energy storage system. We call in short form as battery energy storage system as BESS. So best plant. So best plant is already installed in Kerala. I think now it is functioning in Kasaragod district, Mailati power station. So they have started this kind of what I am mentioning now. In Kasaragod, we have a solar power plant installed by Kerala State Electricity Board (KSEB) of capacity. I think it's a bigger one, somewhat on 500 kilowatt to 1 megawatt or more than that. I don't know whether Sugesh sir can add or that one. It's a bigger one. So there now itself that's what I'm saying. Even KACB is ready to install a best power plant. So I'm talking about a PV battery energy storage system, which is uh, obviously uh, came into the reality. Okay, so I don't want to mention much on that one. You have seen so many systems where you can charge from a DC voltage. So you can charge any battery. Battery is nothing but a small electrochemical device where you can store energy in the form of chemical. Okay, but I think chemical engineers are there. So you can think about that kind of research. So this is even what I am saying is that this is just a point where everybody is talking about how to manage with the solar power in a bigger level, bigger way. So it is just started only. So there are a lot of opportunities on this aspect. So how to do a better charging mechanism, how to do a discharging. So see, think about. I'm just saying about one more aspect here. If you have an inverter, there is no need of another inverter to connect to your battery during night hours, because same inverter which was used for transferring power during daytime can use the same inverter can be used for battery also. During night hours, it will work with the battery. That is a beautiful concept here. So what you need is a solar panel on one side with a small DC-DC converter, a battery bank on the other side with a small DC-DC. We call it as a bidirectional converter because battery has bidirectional, means you need both directions. It's charged during daytime and discharge during night hours. So that's a very beautiful concept of PV battery energy storage system. I hope that is clear. If you have any doubt, you can just ask. Anybody want to ask anything about this one? Because I'm not going to give much details on this system because it is a very common and simple system. Anybody want to add anything on this aspect?
Yes, sir. Hello?
Yes,
Hello?
yes.
Sir, could you please
Yes,
make
yes,
the
it is
slide
audible.
as
Please tell me.
slideshow? Sir, hello?
Slideshow, yeah, just I will put in the slideshow. Then I got a complaint that it is not moving. That's why.
Okay, okay, then no issues. Continue, sir.
Okay. Now it is okay. Is this slide visible?
Yes, sir, it is visible.
Yes,
Any doubt on this slide?
No, sir.
no, sir.
Okay, I think it is clear. The concept is clear.
Hello, sir.
I am happy. My one third of the time I'm uh, almost used for explaining this concept. If this is there, then I think you can do further. This is one basic aspect which I want to convey. And here also there are a lot of aspects, but I will discuss those later only because on the top side you can see I am using some H, Q, and P power flow. That is harmonic power flow, reactive power flow, and real power flow. So that I will discuss later only because for beginners, just I am keeping the real power flow aspects only. Okay, I think that is clear. That just I am going to slide 15. Is that visible now? Hello, is this okay?
Sir, slide 14 is visible, 15 not.
That's what I'm going to. I am just see whether
Now it is visible, sir.
just see whether it is 15 now.
Yes, sir.
Yes.
Now 15. Hello, is it 15 now?
Yes, sir. It is 15.
Yes, sir. 15.
Okay. Then there is an issue if I put it in slide mode. I don't know why it is so. Okay, if it is visible now, I will try to convey this concept also. Okay, so if you see here, the same sun is available and same PV array because we are using the same system to study. And then I'm talking about a small DC-DC converter boost. I'm saying it as boost, boosting the voltage from low DC to a high DC voltage. And I have an inverter which is connected to AC grid. So, okay, I'm pumping the real power from sunlight, the solar energy to converting to uh, electrical energy in DC form, and then making it into AC form and connected to grid, where I have a lot of non-linear substation load or kind of local load grid. It can flow to any part of Kerala. Okay, once it is connected to grid, the substation is in Kasargod. So that doesn't mean it should be used in Kasaragod only. That power can flow from anywhere, isn't it? So it depends upon the demand. It will flow from the power grid. So now the question is, when the local people are enjoying this power, when sunlight is not available, you have to go for a battery energy storage system. But that is the serious drawback of battery energy storage system is cost. We all know the cost of a electric car only mainly because of its battery. If you have an electric car, I think many people may be knowing about a Tata electric car or some other MG or thing. So if you simply want to replace the battery power pack, it will cost half of the price. Okay, out of the 11 lakhs, 6 lakhs is or 5 lakh is meant for the battery power. So that battery stack is having a high cost. So if you think about a bigger power generation system, it's definitely we cannot go for those kind of costly battery power plant. That's why I'm telling about suggesting all our chemical engineers to go for some kind of cost reduction in battery. So a lot of researches are going on, and I think recently I have seen some battery improvement results from ISRO. I think commercially they are going to manufacture those kind of batteries, and in lithium ion itself, a lot of changes are going on with various applications. Okay, battery itself is a big area of research, and any small breakthrough will give a lot of contribution to society. Okay, so I am not an engineer in battery. I have a system where we can operate with the battery. So I know that if you have a battery system, I can operate with the grid smoothly. Okay, smoothly in the sense during daytime, I will use the solar power to charge battery, and evening hours I can discharge and use our power system. Beautiful. Now, as of now, uh, instead of battery, the other option is PV pumped storage system. In a pumped storage is nothing but a small hydro where we used to pump water from a low level to a higher level. Means on the water level in the sense of you can say that water at a lower reservoir and water at the upper reservoir. Something like we need two storage tanks. So obviously, I'm thinking about a hypothetical situation, but now even KSEB, Kerala State Electricity Board, is suggesting a pumped hydro power plant in Kerala. I think somewhere in Pathanamthitta, they have a concrete idea, means design is available, planning to operate that one. It means they have a strong proposal for constructing a pumped hydro plant, especially to meet this kind of demand. This is only in design stage for KCB. And as a researcher, what my student is working on is how to operate this and what are the research level complications. Okay, so what we have proved here is just like our battery energy storage system, it can operate very smoothly, except that there is an inertia part. Okay, so battery can easily discharge within a fraction of seconds, whereas in a hydropower plant, it will take a few minutes or few only minutes. I'm not talking about hours. It's only few minutes. Inertia means it may take few minutes, maybe 5 minutes, 10 minutes, 20 minutes, or 30 minutes, depending upon our that electrical mechanical system. Okay, it is not completely electrical. Chemical energy to electrical was very easy in a battery, but in a hydropower plant, operating it as a turbine. Okay, so it was operating it as a motor first for pumping water from lower level to higher power during daytime and store water there during daytime hours. And evening, if suppose we want to start discharge and deliver power to the load, then it's a small time delay is there. But we are talking about some smaller units, motor generator unit, where pump is used as turbine itself. Okay, there can be a single device which can pump as turbine also. Means same device which can operate as pump and turbine. We call it as pump as turbine concept. So there are systems like that. And motor generator. Even we know, electrical people know that an industrial motor can also work as a generator. VLDC motor can work as a VLDC generator. So it is possible for motor as generator and pump as turbine. With that concept, it is very easy that we can reverse the power generation. Okay, the converter is remain same. This is a beautiful system. We have demoed. I will give some results of this system also. Okay, that are the two concepts. Now the third one is fuel cell. Okay, so I have a lot of explanation on fuel cell, which I think for the safe explanation, I'm leaving some of the characteristics of fuel cells or classification of fuel cells. As you all know, there are something called low temperature fuel cells and high temperature fuel cells. Whatever we have seen normally in our laboratories and all, we have a one fuel cell in our GCK Power Electronics Lab, which is very conventional proton polymer electrolyte membrane, or sometimes we call as proton exchange membrane also. Proton exchange membrane fuel cells, PEM fuel cells, PEM fuel cells. So that's a very common low temperature fuel cell. And there are fuel cells, solid oxide fuel cell, SOFC, which are high temperature in nature, and they can carry more power also. The input depends upon hydrogen or some other gases. Normally, hydrogen is considered as input for fuel cell. And this is the third way of power generation. And this has one big attraction that I will tell you. Just I will come to that one slide. Okay, is it visible? Slide 22. Anybody?
No, sir. It is
I don't know,
15.
it is not visible. I just said slide 22. Escape. Just search issue here. Okay, is it okay
Yes,
now?
sir. Okay, okay.
Okay, after pump as turbine, I am coming to this point. Is that clear? This is the last concept what I want to introduce. That is how to use hydrogen as a storage. I think this diagram is very interesting. You can see that it is a not an electric vehicle, it is a fuel cell electric vehicle. Okay, where the block diagram shows that there is a hydrogen tank, H2 tank, and with that H2 tank we are feeding a fuel cell, and fuel cell is controlled with a PCS, power conditioning system, and fuel cell is output is electrical, which will drive a motor, and that mechanical power from the output of the motor is connected to the wheels. Okay, the car start running. So that is called a fuel cell powered car. And that concept is a very established. Fuel cell powered car is an established technology nowadays. Established in the sense it has come into models and means commercial vehicles now. Tesla has, I think, fuel cell powered car already in the roads. And I don't know whether it is available purchase in India that you can check out. But at least these cars are now available as a electric vehicle now. Okay, now my concept is how this is connected with the grid. Okay, so you can use the same vehicle as a power plant also, because you have a hydrogen and you are investing a lot on fuel cell stack. Then why not you use this hydrogen fuel cell stack concept to connect it to grid? So that is also when I thought that it's a very new idea. It is not at all a new idea. You can see that fuel cell electric vehicle car as power plant is given in reference 5. Okay, people have already uh, explained that concept. And in one paper, it is mentioned that if you replace all your existing cars in the world with the fuel cell powered cars, and then use it for connectivity with the grid. Okay, during night hours, suppose your car is free, connect all those cars to grid. Then, as per the paper, the mathematical calculation shows that you can meet the present demand of electrical energy in the world. That is very interesting. Okay, with all these cars, you can meet the electricity demand of the world as of now. Means the present demand, you can shut down all your thermal, hydro, nuclear stations and make all your cars as fuel cell. That's a very interesting aspect. I'm also very much fascinated with that concept. Okay, with the hydrogen alone, you can power your whole world. And during, it's a hypothetical situation, but at least that is what the scenario. Then why do you want to make a fuel cell powered power plant separately? Because when you have this kind of device already. So that is what the concept. Okay, with these three concepts, I'm also almost come to our basic level of energy storage system. These are the three way of energy storage which I want to suggest. Okay, and in these three areas, my three PhD students worked very well. I mean, one student worked almost 3-4 years on solar PV, and I think Dr. Nirmal Mukundan, he got PhD in that area and now working as a postdoc reference. I don't know whether he is available here. He is going to take the lecture during after my session. Nirmal, are you joined?
Yes, sir, I will. Hello?
Okay. Then I don't want to tell more. Okay. So you can give some of the aspects and that aspect.
Yeah,
And
correct.
okay. So I'll convey in another 10 minutes also. Okay. And the another aspect is on this storage aspects, we have worked with fuel cell. One PhD student worked on fuel cells. And as I already told you, the concept is very clear. But what we can do as a researcher is we can demonstrate how this can be used for connecting to grid and what are all the improvements that you can make. I will just convey some aspects of that one. Okay, so how this can be connected to grid and okay. So is this slide clear? 24. Hello, I think we have something around 100 people here. Please,
Yes.
whether
Yes.
24 is available? See,
Yes, sir. It is
Yes,
Yes,
sir.
visible to
sir.
you?
Yes,
Yeah,
sir.
yeah. It will give an interesting information that you have a lot of industrial players or manufacturers who manufacture fuel cell electric vehicle. Okay, so we can take a lot of literature and start working on. It's a multidisciplinary area, as I told already. It's not only an electrical or mechanical or civil, chemical, and even civil also come into picture. Unfortunately, in fuel cell, civil people much role is not there, but you can see in a pumped hydro, a lot of work can be done by the civil people also. It's basic concepts. Then how these companies are going into fuel cell vehicle, and then okay, and vehicle to grid V2G market. Lot of studies are going on, and then okay, then let me come to some aspects of fuel cell. Okay, so then obviously in why I am paying interested to tell about this aspect is, so in research we normally focus on what are the things already done. Okay, you can see here the slide 29. It is about connecting your PV fuel cell with the grid. Okay, so PV is there, fuel cell is there. You can use it as a car as power plant, or you can use this instead of car. You can make it a fuel cell power plant also. So I think we have published one paper on a fuel cell power plant working along with PV. Okay, so we have seen done a lot of research in the literature. That means how many people have published papers on these aspects, and we have seen many control aspects, how these inverters are controlled, like IRPT, instantaneous reactive power, LMS, SOGA, BSGA, MCCF. Those are all control techniques for these inverters, and how these are used for these kind of inverters. And this is one system which we propose. Okay, I think 34 is visible. Then one system we proposed is like a PV panel is connected with this grid with the help of a converter there, and a fuel cell stack. It is not a car. It is only just a fuel cell power plant. Just a fuel cell stack, hydrogen tank, and the output from the fuel cell is again a DC voltage. You are connecting with the grid with the help of a converter, and we have an electrolyzer here. That's what the interesting part in this paper. So the electrolyzer is nothing but a device which is fed with electricity, a DC power supply. For its two electrodes, it will give it electrolyze our water and liberate hydrogen. Okay, so the electrolysis of water will give you hydrogen, and that hydrogen can be stored in a tank. So during power availability from PV panel, instead of pumping all power to grid, if there is a restriction that you can pump only this much power to grid. Okay, in power system, that kind of restrictions are power from load as percentage. So the excess power can be used to electrolyze water and produce hydrogen. And fuel cell can be used when solar power is not available. You can start operating this fuel can and make the power injection to grid. Okay, this is actually a DC bus, DC power, and then you have a common inverter for all these three purposes and connecting to grid. So this is what the interesting aspects of this system. And the system is, as I told, it is not at all a complicated system. But the only thing is that how you control it is actually the important part. And in this paper also, we have focused more on that aspects, how this inverter is controlled and what are the signals to be sensed. And you might have seen for a first person, it may be a complicated one, but for electrical people, if you go into depth, it is, you can understand that this kind of inverter is, we have developed some control aspects in this one, which I don't want to go much into details. If somebody is interested, you can contact me, or I will get to lead to my student also for more discussion. Not the Nirmal Mukundan. This is Suresh Kumar. I think I will give his details later. And even control aspects also. With this, I'm keeping out of the scope. And one aspect what I is sizing of this hybrid system. Okay, what should be the power of solar plant, solar PV plant, and what should be the power of your hydrogen fuel cell power plant, and what should be the power level of your uh, the electrolyzer. Okay, so I think we have designed a optimum power level for all these three based on some calculations, and that calculation itself take time. So I will just come to the conclusion of that calculations. Yeah, I think this is what our calculation conclusion. We have shown that if you have a two, I think is it clear? 47.
Yes, sir. Yes.
Yes, sir.
Okay. Yes, yes. Just see that we have a 290 kilowatt solar panel and 48.3 kilowatt fuel cell and 133 1 kilowatt electrolyzer. So this can these with these three devices, what we have demonstrated is we can inject a constant power to grid. That's the interesting aspect. Okay, normally we people say that solar and the solar power is variable nature. 290 kilowatt peak means this 290 kilowatt it will produce only at peak sunlight hours, maybe 12 mid noon. All other period it will go less than that only. So that's the variability of a solar power plant. But the interesting aspect of our system is we'll inject a constant power. I think it is 50 kilowatt. Yeah, the power rating of what we connected to grid is a fixed power. I think it's a 10 kilowatt. Yeah, we have a 10 kilowatt scheduled power to utility. We are ensuring that it will operate as a single unit which inject 10 kilowatt on 24-hour basis. Okay, then there is no question of variability. So we have seen all predictions here in variations of solar plant, and ultimately the grid people can see this as a 10 kilowatt without any variations. And uh, we have demonstrated this performance with certain graphs and all. I think this is one graph which quickly I will just mention that if there is a power change, these are all variations we have produced in the simulation system. Okay, we have done some kind of simulation. So solar power is suddenly reduced to this level at this second. What will happen? So every time we have seen that our power injection to grid is constant. Okay, so that part we were able to manage with this kind of system. And another aspects we have proved here is we have the system improve power quality also. Okay, that power quality in the sense, normally we say that at the distribution side, we have a reactive power issue. Sometimes we need to install capacitors for maintaining the grid power factor. So those reactive power, it is to maintain the reactive power demand of the load. Okay, that reactive power also the same inverter can provide. Another aspect we have demonstrated is the harmonics at the grid side. Okay, the harmonics at the local grid side, we can have a the reduction. Means suppose if you are installing this device in a commercial area near to a hospital, along with a hospital. So there are a lot of hospital roads which produce harmonics in current. So with the same system, we can absorb all those harmonics, or we say that it is compensate all those harmonics, and we make a clear power or quality power to the grid. So if you think about a utility, so I'm installing a unit which can give a real power. It will act as a constant 10 kilowatt system, and then it provide improvement in power quality also. That's what our conclusion there. Performance and as everybody know nowadays, simulation never permit us to publish in good quality journal papers. So we need to have some kind of hardware experiments and prove the result. For that, we have purchased fuel cell, hydrogen cylinder, and all our experimental setup of hybrid systems. So everything is available now in Kannur Engineering Lab. I want to make a publicity and make use of that lab if anybody is interested. Okay, and there are good teachers also, which they will be, Sukesh sir will be able to convey you. And unfortunately, I am now staying a little far away from Kannur, and I can also support people, those who are interested to work in Kannur. Okay, so with this concept, with this hardware setup, we have demonstrated the performance of a real system also. Okay, so but in the real systems, we are talking in terms of watts only. Okay, 31 watt load, 150 watt, 4 watt grid power, a 185 watt inverter, 386 watt PV, the 88 watt electrolyzer, and power fuel cell. I think it is 100 watt. Fuel cell, I think we are operating toward 219 watt fuel cell. So I think our fuel cell is 1 kilowatt fuel cell. We are able to operate even at 500 watt also. So the system is still in working condition. We have demonstrated this performance of the new system, and even we have plotted all these graphs in our DSO test and compare. And obviously, in order to publish this kind of result, we have to demonstrate that our system, proposed system, which is in 72 number slide, can see the last one. The proposed system is much better than all our existing papers 19, 20, 21, 22, 23, 26, 27. All those control methods and whatever we have proposed is showing adaptive, excellent, with low computational complexity and excellent performance with active power injection, etc. So with that, we were able to publish that paper, and it is available now right now in IEEE Explore. Okay, so hopefully I will quickly go into the PV water pumping system also, pumped storage system also. This pumped storage system also we have demonstrated at, I think I will show one of my, okay, just I demonstrated this. Okay, so this is what our pumped storage system experimental setup, where we have PV emulator, lithium ion battery, motor generator unit, bidirectional DC converter, and then I think for bidirectional DC-DC converter is used for as a pumped storage plant. Okay, with that smaller also we are able to demonstrate some hardware results, and even PV battery energy storage system we are easily able to demonstrate the performance as a hardware unit very easily, and we demonstrated the simulation and result. And I am giving you all our references which we have used for all these studies. I think in our study, almost 60, 82 references here, which we have referred. And our publications, because if you can see this, it is published in IEEE Transactions on Industrial Applications in 2022 by Suraj Thermal Mugundan and myself. And we have published one or two conferences. This is all these publications are related to fuel cells, and all these publications are related to our work on pumped hydro and of battery. Okay, so that work is going on still. And then I'm giving in 117 this slide. This gives our research lab of EEE Department of GC Kannur. What are the available facilities there, and research labs, and we have a wind energy conversion system also, which I was not able to cover in this scenario, but one of my PhD students worked on wind energy conversion system, which is a type 4 wind energy conversion system, and we have used this particular experimental setup, which we were able to set up in our power electronics lab with the help of I think this is a Delhi-based supplier, and they were able to give a demonstrating setup for a wind emulator system. Okay, with that wind emulator, and we have a PV emulator also, and we have a battery also in this version. We call it as the microgrid. And with this setup, we can have an independent control with the or with the help of a controller, just kept separately. Okay, a micro lab box. So I think with that concept, I am concluding at this point, and I think sharply I ended up at 7. If you have any questions, one or two questions, I can answer. Thank you all for your patient listening. I hope all of you might have got at least some information about from this presentation. Okay, thank you. Akhil, If you have any query, they can give in our.
Yeah, sir, participants, please, JP sir, Jayaprakash, sorry, it is, I mean, normally we call Jayaprakash sir as JP sir. Sorry for that. Jayaprakash sir has to leave uh, in a train. He has a travel plan at 7. So, if we can have a couple of questions, 2, 3 questions very quickly, so he will be able to answer that. So anybody who has to ask anything, please make it fast.
Yeah, you can put it in your messages also. If somebody can ask or give a comment on presentation also, no issue. You can just give a remarks how whether it was helpful. Yeah, and nobody is able to comment. Prabha Chandran is there. I think she is my Prabha Chandran.
Yes, sir. Good evening, sir.
You are in Kannur na right now.
Yes, sir. I'm in Kannur right now.
Oh, okay. Anybody? I think many people are there from outside Kerala also.
Yeah, most of the participants are from outside Kerala.
Okay.
Mm.
So participants, please just convey at least how was presentation. Any takeaway from this lecture? At least one feedback. I will share the slides with our coordinator so that you can ask it from him.
Yeah, we'll
I
share
happy to
it
share.
in the group, sir.
Yeah. I already shared that slides with our coordinator, Person Agri Chakko. I think it is there. Anybody, please give a remark and then so that we can wind up. Any participant? I think somebody was answering my questions in between.
Okay, in between, before the participants comment, I just want to ask a quick question, sir.
Yes, yeah.
See, we have the renewable energy penetration in the actual power system, because our power system is a very sturdy kind of thing with a lot of base power. Okay, but renewable energy always caters to not to the base power, right? So how much penetration can be possible from the renewable energy side compared to the conventional side?
Yeah, that's actually the prime concern for any power system engineer. I think at the very beginning, initially, I was also fascinated with the 10% penetration. I think I remember one of my studies I conducted in 2012 or so about the effect of 10% prediction in Kerala power system scenario. But later on, what I found that it is possible to have even 100%. So that's why we were able to demonstrate that solar PV with hydrogen and electrolyzer, fuel cell and electrolyzer. So what we have demonstrated is if you have such units, not only renewable along with hydrogen powered fuel cell system and electrolyzer. So consider it as a single device. So it is able to provide 10 kilowatt 24 hours. So where is the question of penetration level? So we have to think about the power scenario in that way. So that is actually a demonstration unit. There can be multiple models also, like pumped hydro plants. I think ACB is thinking that way. So if you have a bigger pumped hydro plants, it is need not be connected with a single solar PV. It may be located two different plants. It can absorb all those variations. Pumped hydro can maybe 1 megawatt or 2 megawatt. Pumped hydro can lot very big variation of a solar power. So in that way, if you think about that kind of models, even I can suggest something about car as power plant. Just I was mentioning about fuel cell power plant. So there is one concept I got from some conference and all. One paper was suggesting like our Uber. Okay, Uber is now giving a power supply to no, not the power supply. Uber is giving our support to transportation with the help of cars. Okay, a similar concept for power generation. So some Uber, you can say that X company, they ask for 100 cars for evening 8 to 9, whether they are ready to inject power to grid. So they can operate it as a peak hour supporting system, 100 cars supporting peak hours, and they can give us a maybe 100 cars of 50 kilowatt each. So 5,000 kilowatt, maybe a 5 megawatt system. Very, very interesting concept I have seen. So these kind of multiple models are coming up. So it's a very bright future for this kind of experiments. Very interesting question. I hope that is clear.
Yes, sir. Yes, sir. That is clear.
Okay.
Participant side, anybody who has to ask anything, please.
I think I will call Srikanth Namdio. Is he from Kerala? No.
No, sir, I am from Chhattisgarh.
Yeah, the Chhattisgarh person. I did all my studies in Delhi only. So I have many friends in Chhattisgarh.
Yes, sir.
Okay, how do you see our presentations?
Sir, it is very good. Excellent, sir.
Hello, sir.
Okay, are you from electrical background or mechanical or civil?
Sir, I am
Hello.
from electrical.
Electrical, okay. Then you are asked for this slides. No, that's why. You can take the slides from the coordinator.
Yes, sir.
Okay,
Hello,
okay.
sir.
Yeah, tell me please.
Hello, sir. I have just one question regarding the solar. So nowadays, for
Yeah.
the bigger solar installation, we find that
Please introduce yourself.
my name is Prithviraj Rane. I am doing PhD in solar engineering from Mumbai. So I am in the verge of my defense. So just I have one query that so when we install a solar plant, generally it is found that it is at a fixed tilt. That means the panels are tilted equal to latitude. We never thought of single axis tracker or dual axis tracker for the large scale installation. So what might be the what might be the reason behind that, or is not there much increase in power if we shift from fixed tilt to single axis or single axis to dual axis, or why the installation are maximum in India of fixed tilt type, generally equal to the latitude, what we find.
Yeah.
So what might be
Are
the,
you from electrical background or mechanical?
I am from the mechanical background, sir.
Yes, that's why this question. Because nowadays the power, the cost earlier, the issue was solar power generation was very costly.
Yes.
Okay, so we have to always think about maximum power plant on our maximum power point tracking from our investment. Okay, if you have invested something like lakhs of rupees on a solar power plant, we always think about maximum power generation. Now the investment on power generation is reduced. Maybe I think now the cost of power generation per watt has come down to something like 30 rupees or so. Earlier it was much higher. So now that maximum concept is now people are not interested. If it depends even slope. You are mentioning about that 8 degree slope towards south, isn't it? That's the
Yes.
concept we use. That even people are now installing on rooftop, which is not even inclined to south. Okay, even inside towards north, slope, because we cannot change our roof always. The roof,
Right.
yeah, that's why we will not get maximum power out of that power plant. Maybe 300, we can say 3 kilowatt power plant. We may get to 2.5 or 2.7. People are happy. That's why nobody is interested to take another investment on that slope and maximum power utilization.
Right,
So
sir.
even I have some experience also, because even if slope is slightly changed, it is not going to change much in the power generation.
So because if we see the orientation of the earth or sun, the earth completely takes 24 hours to get the 360-degree revolution. So if we try to
Yeah.
divide that 360 into 24 now, it is very minute. The difference is very minute, and that change of angle so is only considered for sunshine hours, not for complete 24 hours. What I see.
Yeah.
That might be the reason behind that, because totally for 24 hours we are not going to get the sunshine. Only the sunshine
Yeah,
hours are
correct.
important.
Correct.
And for the
That's
even for
good.
the
Even
right, sir.
I have seen lot of studies in Center for. I did my MTech from Center for Energy Studies, IIT Delhi. They are conducting lot of studies on this maximum solar radiation angle. So
Right,
the mechanical people are doing research there.
right. So
Yeah,
if we
the
divide,
cost involved in this
cost
maximum
involved
tracking
is
is
higher,
high.
sir,
Yeah, that's
because that
exactly.
360-degree by 24 we have to
Yeah,
just consider that value for 8 hours of
yeah.
sunshine hours. So that's why that cost might be the higher on the larger scale, for
Oh,
larger scale
yes.
installation.
Correct.
Right, sir. Thank you, sir.
Okay, which area you are working on for your PhD?
So I'm working on the solar tracker. So I have submitted my thesis,
Tracking system, correct.
solar
That's why
tracking system. I have
you
submitted
have
my
idea.
thesis. I have got the questions from the reviewer also. I am complying to those particular questions. So maybe in the month of
Good.
January, I'll be able to secure the degree.
Okay. Very good. Congrats.
So if
Okay,
I
any
can,
other queries?
what?
I think we'll take any other query from other also and we'll conclude. I'm just about to leave. That's why. Thank you, Prithviraj.
Thank you, sir.
Okay, if we don't have any other queries, maybe we can conclude, sir. So
Yeah, fine.
I would like to extend my thanks
Yeah,
from
next speaker is
the
ready. That's why I'm happy to.
yeah. Next speaker is actually Jayaprakash sir, student Nirmal Mukundan. He's already there waiting. But fine. The presentation was very nice and engaging, and the participants, I hope they would enjoy they would have enjoyed the presentation. So in a very busy schedule, Jayaprakash sir is actually the director of technical education. He has a lot of meetings in minute by minute basis. So even in this very hectic schedule, when we requested him to give a talk on the battery energy storage aspects of solar energy and wind energy, he readily agreed. So with a lot of gratitude, sir, from our coordinator side, I extend my thanks from the coordinator side as well as the participant side. Thank you so much for joining us. Thank you, sir, a lot.
Okay, thank you. It is my pleasure for me also to join with GCK team. That's why the basic reason behind all these things. Anyway, thanks for nice interaction with all you people. And my only suggestion is that whenever you are spending some time for faculty development program, you might definitely interact and gain something. It's always a give and take. So wish you all the best. Thank you. Just I am leaving.
Okay,
So
thank you, sir.
Dr.
So, thank
Nirmal,
you, sir. Yeah.
I think he is ready. So please take maximum inputs from Nirmal also. Okay, Nirmal, I am leaving now.
Yes, sir. Thank you, sir. Thank you very much.
Okay. Thank you. Thank you all. Sukesh and other
Yeah, thank you, sir. Thank you, sir.
coordinators,
Thank
Akhil, Gigi, I think all our colleagues only. Thank you all.
you. Akhil, sir, over to you.
Okay, hope I am audible. So,
Yeah. Please
Yeah.
carry on.
so for today's second session, we are pleased to have with us Dr. Nirmal Muguthan CM, a self-motivated power electronics engineer with strong expertise in renewable energy system, power electronics, and grid-connected solar energy conversion. He holds a PhD in electrical engineering from APJ Abdul Kalam Technological University, Kerala, with his doctoral research focused on the control, design, and analysis of grid-connected solar energy systems. Dr. Nirmal has research experience at leading international institutions, including Khalifa University, Abu Dhabi, Prince Sultan University, Saudi Arabia, and IIT Delhi. His research interests span power quality, smart grid, renewable energy integration, and power electronic converter design. He is a recipient of multiple best thesis and best paper awards from IEEE sponsored conferences. So we are delighted to have him as our resource person for this session. I welcome Dr. Nirmal Muguthan for the presentation. Welcome, sir.